Hey, lesson 2. All right, unit 10. We are on measuring angles and circles. Okay, you guys, you're going to have a lot. You're going to have quite a few of new words jumping out at you in this lesson. Arc is being the big one. You got minor arcs, you got major arcs, you got arcs that are congruent, you got arcs that are beside each other, non-adjacent arcs, that's the ones that are not beside each other. Arc length and radian, lots of words that are about to be thrown at you. We're going to take this nice and slow real quick, though. Real quick. That's oxymoron, isn't it? We're going to take this slow. All right, a central angle of a circle. Basically, it's an angle that's at the center of the circle. So this is a great something to look at here. This is angle ABC. See how its vertex is at the center? This would be circle B, right? Yeah, circle B. So angle ABC is an angle at the center of the circle, or you can call it angle CBA if you want to. It doesn't really matter. That's a central angle. All right. To find the degree of circular rotation, a degree is that angle out of 360 of the circular rotation about a point. So you need to know that a full circle is 360 degrees. That's what you need to know. You need to know a full circle is 360. All right, what do they go for? Okay, that's what they talk about. So add them all three together. Angle 1, angle 2, angle 3, you get 360. You need to get into arc. Okay, there we go. Good. All right, an arc is a part of a circle that has is defined by two endpoints. So this orange arc from P to R is a minor arc because its measure is less than half the circle. So this is a minor arc. It's an arc. All right, so I see they marked the other one green. This is arc PTR. And you notice I said 3 different letters this time because major arcs, which is bigger than 180, is going to have 3 letters. So this is arc RSP, or you can say RTP or PTR or PSR for that matter. But usually it's going to be 3 letters to know that it's going to be bigger than 180. All right, so a minor arc is smaller than half the circle. That's smaller than 180. And then a major arc is bigger than half the circle, so it's going to be bigger than 180. But a full circle is 360 degrees. All right. So a semicircle is exactly 180. So if you said, I want to look at arc RST, that's a semicircle, or you can say RPT, that's a semicircle. Half a circle is exactly 180. All right, which means you have 2 congruent semicircles. Congruent arcs are the same. So RST is a semicircle and RPT is a semicircle. Therefore, they're congruent arcs because they're the same measure. All right. So then it gets into, looks like naming arcs. So angle 1 is saying it's congruent to angle 2, which means that arc FG, which is made up of angle 1, see, angle FLG or GLF is F and L arc. And then angle 2 right here is angle HLJ or JLH, however you want to say it, but it's arc HJ. These arcs are congruent. So if angle 1 and angle 2 are the same, then arc FG is the same as arc HJ. They are congruent to each other. All right, adjacent arcs does not mean they're necessarily equal to each other, just means they're sitting beside each other. So HJ, which is this orange, is adjacent to JK, arc JK, which is green. So it doesn't necessarily mean they're equal, it just means they're right next to each other. All right, so let's see what's next. Arc addition postulate. Okay, so they're saying that you can put 2 arcs together to make an arc. So if I'm looking at arc ZY, and I'm looking at arc XY, then if I add those together, I get arc XZ. So these 2 arcs independently can add up to be XZ's arc. All right. All right, here we go. Example number 1. Find X. Well, X is an angle. It's a central angle because it is at circle A, D, A, E. A full circle is 360, and I happen to have every single pie piece besides the X. So I'm going to take 360, and I'm going to subtract 85, 40, and that box means 90 away from 360, and that will be my answer for X. So grab a calculator. 90 plus 40 plus 85 is 215. I'm going to take 360, subtract 215, and what I will have will be my final answer. So 145 degrees. So angle X, the central angle DAE is 145 degrees, which means arc DE is 145, by the way. Okay. Got to check here. Okay, so we need to find X again. A full circle is 360, and I happen to have the other two central angles besides the X, so I'm going to add those together. 165 plus 145. Here, I'll do it out for my visual people. My goodness, apparently I can't type. Equals 360. All right, now subtract those two from the other side, or add them and then subtract the sum, which is fine. You're going to get the same answer, so it doesn't really matter. And you're going to get 50. So X, 50 degrees. Where's my degree? Boop. And there we go, 50 degrees. Okay, by the way, that makes this arc right here 50. And I'm sure we'll get into that in just a few minutes. Okay, now we're done with that. Move on. Example number 2. PM, that's my radius. I'm sorry, it's my diameter. PR is my radius. PM is my diameter of circle R. Identify each arc as major, minor, or semicircle. Then find its measure. Okay, here we go. MQ. They want MQ. Well, first off, I noticed they use 2 letters, and MQ is smaller than half a circle. So MQ is a minor arc. All right. So the measure of arc MQ equals MRQ. Okay. Hang on a second. Okay, so they did the major, minor, semicircle for me, so it's minor. Okay, then find its measure. Okay, so I guess they're going through how to find the measure. Okay. Well, first off, I guess I need to know what this angle right here is. And since PM is a diameter, then PQM arc is a semicircle, which is half of 360, and that's 180. So if PQM is 180, and I know P to Q is 115, to find the leftover, Q to M, I'm going to take 180, subtract 115, and that will be Q to M. 180 minus 115 is 65. All right, so it is 65 degrees, which means the measure of arc QM is 65. By the way, central angle and its arc are the same. Said it before, but I want to make sure you understand how we're doing that. They're equal to each other. Okay, well, we got M, N, P. All right, M, that's my starting location. N is what I'm heading towards, and I'm stopping on P. So I'm starting on M. I'm going towards N, stopping on P, and that is a semicircle, which means it is 180 degrees. Therefore, the arc is 180. All right, M, N, Q. Starting on M, going towards the N, stopping on Q. M, N, bypassing P, stopping on the Q. So I'm looking at M, N, all the way to Q. Well, if M, N, P was 180, and I add on PQ of 115, 180 plus, 115 would be MNQ. So take 180, add it to 115. Okay, they did not do that. They did not use the arc addition postulate. They said, okay, well, we know a full circle is 360. So if we take 360, subtract 180 and the 115, we'll get the leftover QM. Or, hey, 65 from the QM. I just assume these problems were separate. That's fine, no big deal. So 180 plus 115 or 360 minus 65 gets the same answer. So 360 minus 65 is going to be 295. All right, 295. Okay, online activities. Okay, so you must have some kind of online activity. If you guys want to go through that, that's fine. I'm going to move on to the check. All right, it says GJ is a diameter of circle K. Identify each as a major arc, minor arc, or semicircle, then find its measure. Okay, GH. All right, G to H. I noticed they only use 2 letters, which means it's probably going to be minor, and it is. It's a minor arc, and it's 122. Minor 122. GLH. Starting at G, going towards L, stopping on H. G going towards L, stopping on H. Well, it's definitely bigger than a semicircle because GLJ is the semi. And I need to know what this leftover right here is to add it in. All right, so you can do it a couple of different ways. You can say, hey, this is a semicircle, so 180 minus 122 would be this little leftover right there. And it might be the easiest for students to see if you're a brand new teacher. So 180 minus 122 is 58. So this little angle right here, HKJ, is 58 degrees. So a semicircle 180 plus the 58 more would give you 238. GLH, 238. Oh, I'm sorry. This is a major, by the way. Major arc. All right, GLJ, GLJ. There's your semicircle. And automatically 180. All right, moving on. Example number 3. Find the arc measure in circle graphs. All right, the circle graph shows how teenagers spend their time online. Find the measure of arc DE. Hang on a second. Where's my graph? Circle graph shows how teenagers spend their time in D. Where's my graph? Okay, let me take a break for a second. Let me pull out my book because I don't have my book out. Let me do that real quick. All right, so apparently that this right here is what's in the book, and I bypassed it because I saw this is something I thought maybe that was online activity or something from the next example. So my apologies. This is what it looks like in your book. You got teenagers, online activities, and then male participation in sports. So I'm on page 579 of your consumable workbook, page 579. And if you do not have your book in front of you, shoot back to the previous page. You can see what we're doing right there. Okay, so let me go back to example number 3 because they didn't put it on the same page, which I can say is probably a little frustrating for everybody. All right, so we're finding the measure of arc DE. All right, DE, everybody, is right here. It says 12%. So they're asking us to find 12% of a full circle 360. So we need to find 12%, 0.12 times 360. So 12% of 360. So that's a minor arc, by the way. All right, so we need to find 12%. Oh, they want the name of the angle. Okay, so it would be angle DPE. We need to find 12% of 360. So 0.12 times 360. And I'm going to grab my calculator. 0.12 times 360 is 43.2. All right, so the measure of arc DE, 43.2, which is the measure of the angle, the central angle. All right, done with that. Oh, we got a check coming up. All right, the circle graph shows the percent of male athletes that are involved in each type of sport at a high school. Find the measure of CD, so arc CD. Find it to the nearest tenth if necessary. All right, so CD. All right, shooting back. C to D is 17%, and it's basketball. I'm trying to find 17% of 360 degrees. So everybody grab your calculator and put in 0.17, because that's 17% times 360, 61.2. So it's going to be 61.2. All right. Moving on, at the bottom of page 579 on your workbook, example number 4, use arc addition to find measures of arcs, and then want me to find the measure of arc WY. All right, so WY. So I'm looking at 90 for the box. That's WX. And then 62 for the X to Y. Add that together, and you get XVY, which would be the arc X, WXY. So 90 plus 62. 90 plus 62, everybody, is 152. All right, got a check. Moving on to the next page. Page 580 in your workbook has a check right there, and they want the measure of arc AD. All right, circle F. So A to E is 63, E to D is 90. So AED would be 63 plus 90. 63 plus 90, everybody. So grab your calculator. If you can't do that in your head, it's going to be 153. Okay. Let's see. Okay, arc length coming up in your workbook. Now, there's a formula for this, everybody. Arc length is the angle that you're talking about out of 360 times the circumference, 2 pi r, or diameter times pi. Either way, you need to know what your radius is, because there's that's in the formula. All right, so you need to know this formula, everybody. You need to know arc length is the angle over 360 times 2 pi r. 2 times pi times your radius. All right, angles can be measured in radians, and if you're going to take calculus anywhere in your future, you need to know this as well. A radian is a unit of angular measurement equal to 180 divided by pi. So you need to know this, 180 over pi. And this is honestly how you would change degrees to radians, radians to degrees, back and forth. So you need to know this particular one after you leave geometry, especially if you're going into calculus, anything like that. Here it is right here. To convert a degree to a radians, it's pi over 180, and convert radian to degrees, it's 180 over pi. You need to know this right here for sure if you're going to take calculus. All right, moving on. Example number 5. Okay, let's see here. We got to find the length of AB. Now, I want you to notice it didn't say find the measure of AB. There's no M in front of arc AB, which means this is arc length. So subtle difference, students, and if you're a brand new teacher, make sure you point this out. If there's an M, that's the measure of the arc, which means whatever the central angle is, the arc is. When there's not an M here, this is arc length, which means you have to use your formula. Angle over 360 times 2 pi r. All right, so it looks like they did kind of this one for us. They want AB, and that means 80 is your central angle. So we put that over 360 times 2 times pi times your radius. And they say the diameter is 14. See how the entire line here is labeled 14, which means my radius is half 7. Or you can just put 14 pi. It does make it quite a bit easier. Again, if you're anything like me, you like to leave it in terms of pi to get your students prepared for what is coming next. And that is leaving pi in answers. All you're going to do is take 80 divided by 360 and then times 14. Do not put pi in your calculator, and you're going to end up with 28 pi over 9. So 28 pi over 9 is what I prefer. 28 pi over 9. But they want a decimal answer. So go ahead and multiply by pi on your calculator. But 28 pi over 9 is really what I'm looking for as a teacher for myself. And they want this as a decimal. So 9.77. Right, there we go. There's arc length. All right, here comes another one. Find the length of PQ. Again, there's no M. That means you're not looking for, hey, it's just 45 degrees or 45. They want arc length. So it's going to be 45 over 360 times 6. Because if the radius is 6, the diameter is double that. So times 6, and then stick a pi symbol right after that. So it'll be 3 pi over 4 or 3/4 pi. So again, one more time, 45 over 360 times 6 would be 3/4 pi. Or if you want to leave it, as a decimal, that's fine. Not particular with me, but it's fine with them. 2.3, and it's a 5/6, so we'll make that 5 go up to a 6. So 2.36. All right, there you go, my lovelies. All right, example number 6. Okay, good. They actually teach this. All right, convert from degrees to radians. Okay, so you need to know the formula. The formula for degrees to radians is pi over 180. So basically, you just take your angle and divide by 180 and stick a pi with it. It's super easy. So 135 over 180. And of course, you're going to get 3/4 on your calculator. Stick a pi with that. Boom, you got your answer. So it's 3/4 pi. So this is going to be 240 over 180. And then stick a pi with that. So it'll be 4/3 with a pi. So 4 pi over 3. And again, older teachers like myself, we like to leave it like this. It gets them ready for the ACT because the ACT does not do decimals. And it gets them ready for what comes next. All right, done. 4/3 pi or 4 pi over 3. How do you want to write that? All right, radians to degrees. All right, which means you got to flip flop the 180 and the pi. So now we're taking 180 over pi and you're multiplying it. All right, so basically take your pi's and cancel them out. Pi's now go away. And so you're going to take 11 over 6 times 180. And the pi's cancel out. Looks like it's going to be 330. All right, so the check, 2 pi over 3. The pi's cancel each other out. So you're multiplying 2/3 times 180, and you're going to get 120 degrees. I think that one's the easy because the pi just completely disappears. All right, example 6. So we got here, we're going to find the length of ZY. And again, they say find the length. This is arc length. There's no M here, which means it's not just 3 pi over 4. So we got to use the formula. But first thing I would think is what they would want to do is change radians to degrees. I'm not really sure. No, looks like they're not. They are taking the theta equals the arc length over the radius. So they're taking the 3 pi over 4, saying equal to the arc length over the 9, which is the 9 is the radius, and multiplying by 9 on each side. Okay. So I don't know that I would have done it this way, but I like it. It's a shortcut. That's perfect. So we got 27 pi over 4. In my calculator, it looks like that's going to be about 21.21. All right, 21.21. There's your arc length. All right, so we need to find, so the length, okay, 21.21 centimeters. All right, fantastic. Okay, we have a check here. All right, so we need to find the length of MN. Again, there's no M here, which means we just need to find arc length. So take your 7 pi over 12. It would go right here. You're basically going to multiply by whatever your radius is, which in this case it's 2. All right, so take 7 pi over 12, multiply times 2, and you're going to get 7 pi over 6. 7 pi over 6. 7 pi over 6. Okay, so to the decimal would be 3 point. All right, now it's 665, so it'd be 67. All right, another example, go online. By the way, leave it in terms of pi. Okay. Oh, practice is up next. All right, you guys give it a go. Have any questions, ask your teacher, ask me. You guys have a great day. See you later.